All right, we are on, what are we on? 5.2, page 2. So again, we are doing verifications here. It talks about converting sine and cosine when there appears to be no fractions to add, no products to find, or no opportunities to use Pythagorean identities. Let's see if we can rewrite certain sides in terms of sine and cosine. So definitely we see this if everything is in terms of tangent, cotangent, cosecant, whatever. In this one, we can do either one. You could pick either side, and it's probably just as easy. In fact, I think maybe doing the right side might be easier, but we're going to do the left side. So we're going to change everything. So tangent is going to be sine x over cosine x plus cotangent, which is cosine x over sine x. Okay, that equals secant x cosecant x. We're going to multiply this side here because we need a common denominator, so we're going to multiply it by sine x over sine x, okay, which equals 1. We're going to multiply this side by cosine x over cosine x. And again, we're doing that. Sine x over sine x is 1. Cosine x over cosine x is 1. This way, multiplying it gives us a common denominator. This gives me sine squared x over sine x cosine x plus cosine squared x over sine x cosine x equals secant x cosecant x. All right, put these together. We have sine squared x plus cosine squared x all over sine x times cosine x equals secant x cosecant x. All right, sine squared x plus cosine squared x equals 1. So we have 1 over sine x cosine x times cosine x secant x cosecant x. Okay, it's in a little bit different order, but we just split this fraction up. So this fraction would be 1 over cosine x times 1 over sine x. And the reciprocal property tells us that 1 over cosine x equals secant x. 1 over sine x equals cosecant x. So secant x times cosecant x. Check. All right. Same thing here. We're going to change. Again, you can pick either side. We'll go with the left side. I don't know. Just default to the left side. Cosecant would be 1 over sine x. So we're putting everything on the left side in terms of either sine or cosine. Minus sine x equals cosine x cotangent x. Okay, let's get common denominator. So this is going to be 1 over sine x minus sine x times sine x over sine x. I'm doing all the steps here so that everybody understands what we're doing. We're multiplying sine x by sine x over sine x. We're doing that to get a common denominator again, and because sine x over sine x equals 1. 1 over sine x minus sine squared x over sine x cotangent x. Okay, so we have 1 minus cosine squared x, what did I say? What am I talking about? 1, well, it is. It's 1 minus, let's do this, do all the steps. Sine squared x, I'm getting ahead of myself. All right, so hopefully you're all following along here. Now, 1 minus sine squared x equals cosine squared x, Pythagorean, over sine x equals cosine x cotangent x. Okay, I can split this fraction. I can split this up to being cosine x times cosine x over sine x. And the quotient property tells me that cosine x over sine x equals cotangent x. So this is cosine x times cotangent x equals cosine x cotangent x. I have verified that. Okay. Let me down here to 3. And, well, since it says, again, we could do either side. I think it actually is easier to do left side. Maybe not. anytime we have a fraction, we probably want to simplify that. And it's giving us a little hint. It says think about conjugates. So since it's giving us that big hint, let's do that. Let's multiply this by 1 plus sine x over 1 plus sine x. 1 plus sine x is a conjugate of, right? Those are conjugates. I multiply top and bottom because that equals 1. Okay, secant x plus tangent x equals cosine x 1 plus. For right now, I'm not going to distribute that in because sometimes they cancel out, so I'm going to hold off. This is going to be 1 minus sine squared x. Hopefully you understand that math. Okay. Let's see, we can, well, 1 minus sine squared x, that equals cosine squared x, right? Cosine x, 1 plus sine x. 1 minus sine squared x equals cosine squared x, which means that and that cancel out. That leaves me with secant x plus tangent x equals 1. That's why I didn't distribute it in, the cosine into here, because I thought maybe something would cancel out. Okay, let's split this up, this fraction up into the sum of two fractions. So 1 over cosine x plus sine x over cosine x. Okay. 1 over cosine x is secant x. Sine x over cosine x is tangent x. So I have secant x plus tangent x equals secant x plus tangent x. Check. I have verified that one. Okay. Let's do the last one. Let's see. Well, let's just start off by doing the conjugate and see where that kind of takes us. Well, actually, let's do this. Minus 1. That's not. I was thinking about this side, but I think that side's. I think we need to go on a more complicated side. So let's say instead of thinking about conjugates, but before we do that, let's think about cotangent squared x. So let's see, when I have sine squared theta plus cosine squared theta equals 1, and if I divided everything by sine squared theta, sine squared theta, sine squared theta, I have 1 plus cotangent squared theta equals cosecant squared theta. So cotangent squared theta equals cosecant squared theta minus 1. So why don't we do that? Why don't we use this fact and put that in here? So we are actually going to use Pythagorean. We're not going to think about conjugates. I could try it using, because I think my first, by the hint, it makes me think, well, I should multiply by the conjugate of that. But I think anytime we can change one of the trig functions to be the same as the other trig function, that's usually the best first move. So that's what I'm doing here. I'm making this cosecant squared theta minus 1. And this is going to be 1 plus cosecant theta. Now, the difference of squares, a squared, a squared minus b squared equals a plus b, a minus b, right? So I can go over here and I can rewrite this as cosecant theta minus 1 cosecant theta plus 1. Since it's cosecant squared theta minus 1. 1 plus cosecant theta. Now, cosecant theta plus 1 is the same as 1 plus cosecant theta. So these two will actually cancel out. That leaves me with cosecant theta minus 1 equals 1 minus sine theta over sine theta. 1 over cosecant is 1 over sine theta minus 1. One minus sine theta over sine theta, which is another way to write 1, but in version of sine. Okay, common denominators. I have 1 minus sine theta all over sine theta, which equals 1 minus sine theta over. Okay, check. So that's one way to do it. I don't know. I probably could have done something on this side. I could have maybe used conjugate. I don't think I'd want to use a conjugate over on this side. Like I said, if we have a cotangent and cosecant, we want to get both of those under either cotangent or cosecant. We want them to be the same trig function. All right, that's it for page 2. We'll take a break.